Welcome to Neil's Narratives. And on today's episode, mass extinctions. Life on Earth is stubborn. It swims its way through the oceans, marches up onto land, builds forests, grows bones, lays eggs, and takes flight. But the history of life is not just a story of progress. It's also a story of loss. Unimaginable, total, catastrophic loss. At least 5 times in Earth's past, life has nearly been wiped out. We call these moments mass extinctions, when more than half of all species vanish in a geological eye blink. These weren't just bad days or bad centuries. These were entire endings, eras closing in fire, flood, or silence. In this episode, we'll explore the first 3 of the big 5 mass extinctions. The Orivishian Silurian extinction, the late Deonian extinction, and the most devastating of them all, the Perian Triacic extinction, also known as the Great Dying. And by the end, we'll be staring at a battered, empty world, waiting for new giants to rise. Giants we'll meet in the next episode. But first, how do we even know these extinctions happened? How can we tell that whole branches of life just stopped? The answer lies in the rocks. Imagine slicing into the earth like a cake, each layer representing a different moment in time. These strata, the layers of sedimentary rock, hold fossilized remains of organisms that lived and died in ancient seas, swamps, deserts, and forests. When paleontologists started mapping these fossils globally, they noticed something strange. At certain layers, entire groups of species had just disappeared. Not gradually, but suddenly, as if a biological trapdoor had opened beneath them. Across continents, trilobites, brachiopods, coral species, fish, plants, all gone simultaneously. Let's start at the beginning. The Orivishian Silurian extinction, 443 million years ago. The Orivishian period, as we've discussed in the past, was a boom time for marine life. Trilobites thrived, jawless fish explored the seas, and coral reefs grew thick with biodiversity. But around 443 million years ago, this thriving oceanic world collapsed. About 85% of marine species vanished. The cause? A familiar one: climate change. This extinction unfolded in 2 distinct pulses. The first was triggered by a sudden global cooling event, likely caused by the formation of massive glaciers over what's now Africa, which at the time sat over the South Pole. Rock weathering, as well as biological processes, are pointed to as the culprits. Both actions sequestered carbon from the atmosphere, thus allowing more heat to escape the Earth. As ice sheets expanded, global sea levels plummeted, draining shallow marine habitats where most life thrived. Species adapted to warm, stable, shallow waters couldn't survive the plunge in temperature or the loss of their coastal homes. Then came the second pulse, a rapid warming. Glaciers melted, oceans flooded back, but in the abrupt reversal brought by its own devastation, anoxic seas without oxygen. Without oxygen, marine ecosystems suffocated. So how do we know all this? Geologists have found evidence of glacial deposits from this time. Strange rock formations left behind by giant ice sheets. Paired with isotope ratios in rock layers, especially oxygen isotopes, they can reconstruct temperature swings. Fossil records show the sharp before and after contrast. A flourishing marine world abruptly replaced by sparser, simpler life. Life survived, but it was badly shaken. The Late Devonian Extinction, 372 to 359 million years ago. The Devonian was the age of fishes. Jawed fish exploded in diversity. Early amphibians began experimenting with life on land. Massive forests spread across continents for the first time. And then, another die-off. This extinction wasn't a single blow. It was a drawn-out catastrophe, spanning millions of years, with multiple waves. Up to 75% of marine species were lost, especially in reef environments. Trilobites and armoured fish-like placoderms took major hits. What caused it? Here's where things get murkier, but all signs point to plants, or rather, what plants did to the planet. As vascular plants colonised land and grew into vast forests, their roots broke down rock, which released nutrients into rivers and eventually oceans. This nutrient runoff caused massive algae blooms, just like in modern fertiliser-polluted lakes. When the algae died and decayed, it used up the oxygen in the water, leading to widespread anoxia, dead zones where little could survive. At the same time, these massive forests locked away carbon dioxide, triggering a global cooling phase. So once again, marine life faced a 1-2 punch: temperature shock and suffocating seas. Supporting this theory are black shale layers in the fossil record. Sedimentary rock formed in anoxic conditions. These appear worldwide in the late Devonian strata, painting a picture of oceans turning hostile. It was a slow-motion disaster. Life didn't even realise it was being pushed off the edge until it was gone. The Permian Triacic Extinction, 252 million years ago. This was the big one. The Permian period was diverse, strange, and full of innovation. Giant insects buzzed through the air. Reptile mammal ancestors like Dimetrodon roamed, and the oceans teemed with everything from ammonites to sea lilies. Then it happened. 96% of marine species, 70% of land vertebrates, gone. Entire ecosystems erased. Forests turned to deserts. Reefs took millions of years to recover. Nothing else in Earth's history, not even the asteroid that killed the dinosaurs, matches the scale of this apocalypse. So what happened? The answer lies in a place called the Siberian Traps. Roughly 252 million years ago, an unimaginably massive volcanic event began, lasting hundreds of thousands of years. Magma burst through the crust across what's now Siberia, covering millions of square kilometres in lava. These eruptions released staggering amounts of greenhouse gases: carbon dioxide, methane, sulfur dioxide. Earth's climate spun out of control. Temperatures rose by at least 5 to 10% globally. Oceans became acidic, warm, and oxygen deprived. Methane released from permafrost may have turbocharged this effect. The result was a runaway climate catastrophe. Acid rain poisoned land plants. Marine life collapsed under the weight of heat and anoxia. Even the deep ocean floor turned into a toxic, stagnant graveyard. Again, we see this story in the rocks. a thin dark layer marking the boundary between the Permian and the Triassic periods. It's full of carbon isotopes, indicating a sudden carbon injection. Fossil records show a sharp, dramatic drop in species. In some places, just nothing. A silence preserved in stone. Recovery from the Great Dying took tens of millions of years. Life had to reinvent itself, nearly from scratch. But eventually, it did. And the survivors? They inherited a world without competition. A vast ecological vacuum waiting to be filled. These mass extinctions were not just ends, they were resets. Each one pruned the tree of life, cleared the board, and opened up new evolutionary pathways. In the wake of the Permian extinction, early archosaurs, ancestors of crocodiles, pterosaurs, and dinosaurs, began to rise. With their competitors wiped out, and the new niches wide open, they would come to dominate the next chapter of life. Welcome to the Mesozoic era, the age of dinosaurs. But before we step into that world of giants, let's pause and reflect. Mass extinctions weren't freak accidents. They were tied to real, tangible forces, climate swings, tectonic shifts, and planetary feedback loops. And they remind us that life on Earth, resilient though it is always dancing on the edge of disaster. Today, we are that force altering the atmosphere, changing the chemistry of oceans and disrupting ecosystems. We've only just started to understand how quickly things could unravel. But that's a story for another time. On the next episode, the rise of the dinosaurs, the survivors of extinction, and the rulers of a new Earth. Thank you for joining me in today's episode of Neil's Narratives. Really appreciate any type of feedback, like, subscribe. Have a great day. Goodbye.